Let's review some of the key terms from the trigonometry unit. Pythagorean theorem. Pythagorean theorem is to find a side given two sides of a right triangle. Only for right triangles. We use the formula c squared equals a squared plus b squared. Draw yourself an example. Let's say we know the legs, but we don't know the hypotenuse. Then we do x squared equals 3 squared plus 4 squared. How did we know to use x for the c? Because we look at the right angle across from the right angle, that's our c. So that's what goes here. Not because it's an x, because it's the hypotenuse. Then we solve it. 9 plus 16 is 25, and therefore x is 5. Remember also your triples can be very useful. If you memorize them, you have less work to do. What are some of the most basic ones? 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Not a necessity, but definitely helpful. The Pythagorean converse. To find if the triangle is a right triangle. To find out if the triangle is right, given three sides of a triangle. For example, we're told here's a triangle. The side lengths are 3, 4, and 6. Is it a right triangle? So how do we do that? C squared blank, A squared plus B squared. We don't know yet if it's equal, so we plug in. C is the biggest number. 6 squared blank 3 squared plus 4 squared. We get 36, and on the other side, 25. 36 is not equal to 25, it's greater. So it's not a right triangle, it's obtuse. When it's greater, it's obtuse. Greater, it's obtuse. If it's less than, it's acute. And if it's equal, then it's right. Greater than for obtuse, less than acute, equals is right. That's the main thing that we have to look out for, and we'll be asked to figure out if it's a right triangle. Trigonometric ratios. Remember, trigonometry is the study of the relationship between angles and sides of triangles. Relationships between angles and sides of triangles. When we see that we're mixing angles and sides, that's when we use so, ka, toa. So is the sine function. Sine of an angle equals the side opposite over hypotenuse. Opposite over hypotenuse. Cosine of an angle, we'll call it angle B, is adjacent over hypotenuse. And tangent of an angle, like angle B, is opposite over adjacent. Now remember what that looks like when we have a right triangle. Let's say that this is angle B. If looking from angle B across the triangle is opposite, across from the right angle, like we're pointing like an arrow, is hypotenuse, and the remaining side, or the side touching B, that one's called adjacent. We use the inverse. That's when we say sine to the -1 of some ratio, or cosine to the -1 of some ratio. That's when we want to find an angle measure. We want to find the measure of an angle, we do the inverse sine. Let's start with writing what it would look like. So if I said the sine of A equals 3 over 5, I want to find the measure of angle A by doing the inverse sine of 3 over 5. We use inverse to find angle measures. Angle of elevation. This is the angle made by looking up from a horizontal. So we start with a horizontal. Imagine someone standing at a ground, and then the line of sight is they're looking up towards something else. So this right here would be the angle of elevation, this angle right here. Often we finish the picture by drawing a right triangle. So this is how we get the right triangle with the angle of elevation. Angle of depression is the angle made by looking down. So if we're going to look down, that means we need to be high somewhere. And from there, we look down towards something lower than us. So looking down creates that angle of depression. Finish that picture right there, we have a right triangle. Check that out, right triangle. Remember, in both of these scenarios, we can create two right triangles by creating the alternate interior angle, zigzag. Same thing here, we can do the zigzag, alternate interior angles that will be congruent. So I can get a right triangle here and a right triangle here as well. Those are congruent triangles. Usually we'll see these words in word problems. These are our shortcuts, so that we don't have to spend as much time solving for sides or angles of some right triangles. For example, 45, 45, 90 is an isosceles right triangle. Both legs are the same, and the hypotenuse is the square root of 2 times the legs. The 30, 60, 90 is a scalene triangle, but specifically with the angles 30 degrees and 60 degrees. Everything depends on the short leg. The long leg is square root of 3 times the short leg, and the hypotenuse is double the short leg. See you in class.